Hey you guys, welcome back. Let's go through part 2 of the study guide. So this one is all about fractions. I have all the different fraction operations in this chart right here. So let's get into it. Looking through this, the first 3 boxes are all about addition. I got addition problem, addition problem, and addition problem. Let's look at these. Whenever we add, the most important thing is that the denominators are the same. So in the box, they're both 7. When the denominators are the same, that's great. I can go ahead and keep the denominator the same. And now I'm just going to add the numerators. 2 plus -3 gives me -1. This is where those integer rules are still really important that you have to keep in mind. So -1/7, that is my answer. When the denominators are the same, it's so few steps. It's great. Let's look at the next one. -7/12 plus -1/6. The denominators are not the same. When they're not the same, I have to find the LCM, the lowest common multiple. If I was going to write out the multiples of 12 and 6, I'd get 12, 24, 36. If I wrote them out of 6, I'd get 6, 12. Oh, hey, we got a match. 12 already, perfect. So when I go and rewrite this, I'm going to have the same denominators in my problem because I can't add them until the denominators are the same. They have to be the same. So I got 12 and 12 as my denominators. Now, I got to go and change the numerators because I just changed some of the denominators. So this one right here, 12, I didn't change the denominator. So I don't have to change the numerator. This fraction stays the exact same, -7/12. This one over here, I changed the denominator from a 6 into a 12. I did that by multiplying by 2. And if I do it on the bottom, I have to do it up here on the top. So 6 times 2 gives me 12. -1 times 2 gives me -2. And now, when I look through this, I'm going to go and notice that the denominators are the same. Perfect. Keep it in my answer. Now, -7 plus -2. I just get to add the numerators, -9. Now, if this was my answer on the test, you would get most of the credit. But because I can simplify this even further, I'm going to. That's really important. So, -9 and 12, there's a GCF of 3. 3 goes into both of those numbers, so I'm going to divide them both by 3. -9 divided by 3 gives me -3. 12 divided by 3 gives me 4. And notice how I keep the negative in my numerator just like it was up here, okay? That's kind of where those division rules come in. -9 divided by 3, I get a -3. 12 divided by 3, I keep that +4. So it kind of helps you when you know those integer rules to really keep your signs straight. Let's look at the next one. Are the denominators the same? 5 and 4? No, they're not, but I need them to be the same. I know that they have a lowest common multiple of 20. The more you do this and the more you practice, the quicker you're going to be able to recognize lowest common multiples. Okay? 4 and 5, I could list them all out, but the lowest common multiple would be 20. So I turned this 5 into 20 by multiplying by 4. If I do it on the bottom, I have to do it on the top. 5 times 4 is 20. -3 times 4 is -12. I turn this 4 into a 20 by multiplying it by 5. I got to do the same on the top that I did on the bottom. 1 times 5 gives me 5. So now my new problem is -12/20 plus 5/20. So the denominators are the same. Perfect. I can keep them in my answer. Great. Now I just got to go through and add the numerators. -12 plus 5 gives me -7. I can't simplify that down any further. That's my final answer. Let's look at this one over here. These 3 problems are all subtraction problems. Now, we always turn subtraction problems into addition problems by adding the opposite or adding the inverse, okay? A lot of you guys hear that phrase, keep, change, change, and I know that's a really helpful phrase because it kind of keeps you going through all the steps whenever you're trying to turn this into that problem. So, I'm going to keep that first number the same, -2/15. I'm going to change subtraction to addition. I'm going to change the sign of the following number. So instead of -4/5, it's going to be +4/5. So look, I keep the first number the same and I add the opposite. I'm adding the inverse of that number. So looking through this, are my denominators the same? Nope. So I got to make them the same. When I make these the same, I know that 5 and 15 have a lowest common multiple of 15. So I'm going to rewrite my problem, both with the denominator of 15. And then I'm going to go and change the numerators accordingly. So 15 to 15, didn't have to change anything. Not going to change anything in the numerator either. Oops, -2. 5 into 15, I had to multiply by 3. So whatever I do to the bottom, I have to do on the top. 5 times 3 gives me 15. 4 times 3 gives me 12. Now, whenever I add these up, I have the same denominators that'll stay in my answer, 15 and 15. Add the numerators, -2 plus 12 gives me +10. And if this was your answer, I would give you most credit, but because you can simplify, you need to. So there's a GCF here of 10 and 15. Let's see, 5 goes into both of those. I could divide them both by 5, divide by 5. And now I get 10 divided by 5 gives me 2. 15 divided by 5 gives me 3. And that is my final answer here, 2/3. I'm going to write that up here because I'm going to give some of this an erase just so I can get enough room to write this next problem in the box. There we go. All right, look at this one. This says 3 minus -2/5. Now this is interesting because this 3 doesn't have a denominator. It's just a whole number. But I know that every single whole number has an invisible 1 underneath. It's all a denominator of 1 if it's a whole number. So now it's 3 over 1 minus -2 over 5. And now whenever I do that keep change method or I add the inverse, that means the same thing. I'm not going to rewrite the whole problem. Instead, what should I get to do? And a lot of you guys are doing this, which is great. Once you have enough practice, you can become comfortable with this. I keep the first number the same. I change subtraction to addition, and I change the sign of the following number. So now I've added the opposite, added the inverse, or that keep change method. Okay? Now, this problem is just an addition problem. First step in addition problem is, are the denominators the same? In this one, they're not. I got a 1 and a 5. But I got to make them the same. So 1 and 5, they both have a lowest common multiple of 5. That's the LCM here. So they both have a common multiple of 5. I'm going to go and change the numerators accordingly. So I turn this 1 into a 5 by multiplying it by 5. I'm going to do the same up here. 1 times 5 is 5. 3 times 5 is 15. 5 and 5. Oh, I didn't have to change anything. Perfect. I won't change the numerator either. It'll stay a 2. So now I have 15 over 5 plus 2 over 5. The denominators are the same. I'm going to keep them that way. 15 plus 2, I'll add the numerators. Gives me 17. And now, this is an improper fraction where the numerator is larger than the denominator. Whenever I have this, that is not simplified. I always want to turn this into a mixed number. So I'm going to think, how many times does that 5 go into that 17 without going over? Let's see, 5, 10, 15. That's 3 times. That leaves 2 left over, and I keep the denominator the same. So I end up with 3 and 2/5. I'm going to write it up here just so I can give that an erase and have a little more room in the next box. 3 and 2/5 is my final answer there. Give that a little erase. 1 second. There we go. All right. Now this next problem, I'm starting off with a mixed number. Now it's really, really difficult to try and subtract or add with mixed numbers. Instead, what I always do is turn them into improper fractions. It's way easier to deal with 2 numerators and 2 denominators as opposed to trying to deal with an extra mixed number or an extra whole number thrown in the mix. That's kind of hard. So I'm going to turn this into an improper fraction. 4 times 2 gives me 8. 2 plus 3, 4 times 2 gives me 8 plus 3 gives me 11. So now I have 11 over 4. This negative is really only there so I can remember to include it here. I'm not doing 4 times -2. That's not how we do that. I just don't want to leave that negative off, okay? So now I have -11/4 minus -2 over 5. This is a subtraction problem. I'm always going to turn those into addition problems. So I do that. I'm going to add the opposite. First number, don't mess with it. Add the opposite. Add the inverse. So now I got -11/4 plus 2 over 5. Are the denominators the same? Nope. I got to make them the same. 4 and 5 have common denominator. The lowest common multiple is 20. So let's change the numerators accordingly. 4 into 20, I had to multiply by 5. -11 by 5, I'll do the same thing up top. That gives me -55. 5 into 20, I had to multiply by 4. I'll do the same thing up here. 5 times 4 gives me 20. 2 times 4 gives me 8. So now I have common denominators. I'm going to keep that in my answer. And then I'm going to go and add the numerators. Negative 55 plus 8 gives me negative 47. Great. And this is an improper fraction once again. I want to turn it into a mixed number. 20 goes into 47. Let's see, 20, 40. Oh, it goes twice. I'm going to keep the negative from my numerator. I'm going to put it with my whole number. The negative always goes with either the whole number or the numerator. That's where I'm always going to put it, okay? That's where you're going to see it most. So, negative 2, I got 7 left over. And I keep the denominator of 20 the same. I'm going to rewrite it for clarity. Negative 2 and 7 over 20ths. That's what we get as our final answer. Look at the next one. Multiplication. Multiplication is awesome. All I'm going to do is multiply the numerators. Negative 3 times 2, negative 6. And the denominators. 8 times 3 gives me 24. Denominators don't have to be the same. I don't have to find the LCM. All I have to do is multiply the numerators together and then multiply the denominators together. It's the best. This is a 2, by the way. Now, the only thing I have to remember is simplifying. Negative 6 over 24, they have a common they have a GCF of 6, so I can divide both of these by 6. Negative 6 divided by 6 gives me negative 1. 24 divided by 6 gives me 4. And that is my simplified version. Let's look at this next one. Another multiplication problem. All I do is multiply the numerators together. Negative 7 times negative 1 gives me positive 7. 9 times 4 gives me 36. There's no GCF between 7 and 36, so that is my answer right there. Done. Great. Negative 5 times negative 4 over 5. Well, there's no denominator here, but I know when I multiply, I have to multiply the numerators and then the denominators. Whoops. These motion lights always turn off. Oh, there we go. Turn back on. So I'm going to rewrite this, but I need to have a denominator so I can multiply the denominators together. So every whole number always has a denominator of 1. We just don't always have to write it. So looking at this, I got negative 5 over 1 times negative 4 over 5. All I've done is add the 1 as the denominator. So now I have 2 numerators and 2 denominators. I can go and multiply. Negative 5 times negative 4 gives me positive 20. 1 times 5 gives me 5. And now this is an improper fraction. Just like we had up here, I want to go and simplify that. Let's see, I'm going to see how many times 5 goes into 20. Let's see, 5, 10, 15, 20. Oh, it goes in there 4 times. And there's nothing left over. There's nothing left over, so I'm only going to have a whole number. Because this is really just a division problem, 20 divided by 5, just like every fraction. And it's an even whole number, which is perfect, just 4. No fraction left to deal with, just 4. All right, now that's part 2. I'm going to actually pause the video there because I won't have time to go through all the rest of them. So I'm going to pause the video there, and I'll see you guys in part 3.